proportionality theorem. Triangle proportionality theorem, which means we're going to deal with more proportions, okay? This whole chapter is nothing but proportions. So the first one, if a line is parallel, to one side of a triangle, and intersects, which is just another word for touches, two other sides, then it divides the two sides into segments of proportional length. I can't spell. Okay, so if one side of a triangle, if one line is parallel to one side of a triangle, and it intersects the other two sides, then it divides the sides into segments that are of proportional lengths. So if DE, does everybody see line DE or segment DE in my picture? Do we see segment DE in the picture? Yes. If, no? Yeah, okay. Is parallel to AC. Do you have those markings in your picture? Does it show you that DE is parallel to AC? Okay. And then also, does DE touch the other two sides of the triangle? It does. Okay, so that's the intersection. If that line is parallel, then it's going to divide the sides of the triangles into proportional lengths. So this top little bitty segment right here, BD, that I just highlighted, is going to go over its bottom segment, DA. And that is going to be equal to the same setup on the other side. BD. BD. Does that look better? Okay. And then so on the other side, the small segment at the top, BE, is going to go over the segment at the bottom, EC. Okay. So the small piece over the bottom piece, or top piece over the bottom, equals the top piece over the bottom. And then for some reason it missed some words here where that little blank is. That says the converse of the triangle, if you want to fill that in. Okay. I don't know why it cut off words there. So it should be the, and this should be triangle. But basically, if I say this backwards, it's the same. Okay. So, if a line intersects two sides of a triangle and divides the sides into proportional segments, then the line is parallel to the third side. So it basically says the same thing, just backwards. Okay. So this time, I'm going to put my proportions first. If BD over DA is equal to BE over EC, then my lines DE and AC are parallel. Okay, it's exactly the same thing as what was before. It's just reverse. Remember, converse switches your hypothesis and your conclusion. All right, so let's take a look at that first example. What we're going to do is we're going to set up a proportion so that we can solve for x. We're going to set up a proportion so we can solve for x. And these can be set up a bunch of different ways. In order to stay consistent, I always like to start with the variable first. Okay. So let's start with the first one. What is my variable here? X, okay. So I'm doing x. What is on the same side? What's the other segment on the same side of that? 15. So I'm going to put x over 15. And then I have to do it in the same place. So what I need you to do is look at what is in the same place as x, but on the other side of the triangle. 14. So 14 has to go up top with the x. And then what's in the same place as 15, but on the other side of the triangle? 12. Okay, solve your proportion. Cross multiply. We should be able to solve proportions at this point. What? We're going to cross multiply. It doesn't matter which diagonal you do first. I usually tend to do the variable. 12 times x is 12x. Then it is going to be equal to 15 times 14, which is how much? 210. And then what do I do to solve for x? Do I have a 12? How much? Very good. Did we all get 17.5? I want you to try the next one, just like the first one. Okay, set up your proportion, cross multiply, and solve. I want you to try that one. Okay. Tell me how to set it up. What does x go over? What's on the same side as x? 18. Okay. All right. And then what goes in up top with x? 56, right? Remember, it's one side over the same side but the other part. And then what's in the same place as x? Whoops. Color coded them for you. Okay. X over what piece is on the same side as that equals the other side, but in the same order. We did x first, so 56 is in the same place as x on the other side. And we're going to cross multiply. 21 times x is 21x. You'll get 1,008 for 18 times 56. And then we're going to divide both sides by 21. And what do we get? 48. Okay. Now, like I said, some of the time, on a lot of these proportions, you can set them up just a little differently, and you'll get the same result, but I'm trying to stay consistent in how we do this. Which way did you flip it? You did X over 18 equals 20. If you did 18 over X, then you could do 21 over 56. Is everybody okay with that? All right, let's look at the third one. Does everybody see our X? Okay. What is in this on the same side as X, but in the bottom part of our triangle? Okay, so it's going to be X over 36. Now here's where we have to be careful. What does this mean? If I have this, that means the whole side is 55, right? Mm-hmm. And then this part is just this little piece here. So can I figure out what that one is? Mm-hmm. Yeah. Okay. How do I do that? Subtract. What's 55 minus 45? Okay. So that top part's going to be 10. So then how would my other fraction look? There you go. Okay. And then we're going to cross multiply. I'm going to let you finish it. I'm not going to do the work for you. What'd you get? What'd you say? 8. Yeah. Everybody get X equals 8? Okay. All right, try 4. Very similar. What would just this part? 27 is so what? There you go. I'm just looking at when everybody got for the answer.
I ain't getting it. I don't want to do it. Did I set it up right there, Bree? Like with the six?
No. What's in the same place? What's on the same side of the triangle as the X?
6, right?
No, look at your x.
Oh, I did it, God, put the 6.
Yeah, so it's going to be x over what? 7. And again, they gave me the whole piece here, but I don't want the whole piece. I want this little bitty piece. How do I figure out what that is? 27 minus 6, which would give me 21. So then it's going to be 21 over the little piece here, which is 6. So we cross multiply, we get 6x equals 147. And divide by 6, and we get x equals, there you go. Okay, stay on the same side of the triangle. Wherever x is, put either the bottom or the top part, and then do the same method on the other side. All right, let's take a look at this next one. We're going to have to do some labeling. It tells me that PQ is parallel to CD, so that means this is going to work. Label QD. What does it tell you QD is? Look at the top, right above the picture. What does it say QD is? Okay, so we're going to label that in our picture, 14.5. What's the next piece it tells me? BP is 9, so I'm going to label that. What else does it tell me? Okay. And I'm looking for BQ, so I'm going to call that X, okay? Label your picture. Don't sit there and try to remember what everything is and where it goes. If you label your picture, then it's easier for you to set that thing up. So I want you to go ahead and solve that for me. Set up your proportion. Tell me what my proportion should do. X over what? Okay. Is going to equal 9 over 15. I looked at it. Thank you. And then we divide. And we get. Did she do X over 9? That'll work. If she's got to stay consistent with that. Can't like diagonal across. It's got to go straight across. All right. Flip your paper over. We're going to do that last example at the top. The rest of it we're going to hold on to until tomorrow. Okay, so we're looking at the very top. Very top of the page on the back. It's very similar, but also a little bit more difficult. What I want you to do is label the 2 numbered pieces that it gives you. Label your 2 numbered pieces. I'm going to draw it up here on the board just because I don't have enough room to work up there. All right, what's the first piece of information it tells me? GB is? Okay. Then it says BF is? Okay, and then GH, so that's the whole side here, is 21. Everybody okay with that? Now here's where it gets a little tricky. They want me to find both GC and CH, correct? So, excuse me. I can't use 2 separate variables because we can't solve a proportion with 2 different variables. So I'm going to call this one X. Okay. And what I want you to do is look back at this other one. Like right here. On number 4, how did we figure out what 20, how did we find 21? We subtracted. We did the whole piece minus the top part, right? What's the whole piece here? What's the top part? X. So what we're going to have to do is we can't, because this isn't numerical, we're just going to have to leave it as the whole piece 21 minus the top piece, which is X. Okay. Just because it has a variable doesn't mean we're doing it any differently. It's still the whole side minus the top part that I called X. Is everybody okay with that?
Yeah.
All right. So let's set up our proportion. What is X going to go over? What goes on top for the other side? Okay. Over. Did anybody have any questions on how I set that up before I keep going? Yes, you do have questions on how I set it up? Okay. All right, let's cross multiply. I'm going to do X times 4.8, which is just, but here's where we have to be careful. Have a seat. I'm not done yet.
Yeah.
No, have a seat. No, have a seat. Have a seat. I'm almost done. Just give me a few minutes. How many pieces does this have? 2. So when I multiply, remember we've done this before. We're going to put that 14.4 and we're going to put these 2 pieces in parentheses so that we can distribute. Am I ready? Yes, ma'am. Hold on, I don't know what it is. Give me just a second. All right, ready? This I don't need to do anything with right now, so I'm going to bring it down. I need to distribute. So with your calculators, multiply 14.4 times 21. We have 2.4. And then we're going to multiply 14.4 times that negative x, which just gives me negative 14.4x. I'm going slow just to make sure everybody understands where I got the numbers from before I continue. Are we kind of okay with that? All right, I have x's on either side, so I want to take this x and I want to move it over here, and I'm going to do that by adding, right? So I want to do 14.4 plus 4.8. And then divide. What is 302.4 divided by 19.2? So x equals 15.75? It is a lot of work, yeah. Not on this one. All right, so, but it asked me for GC and CH. If GC is x, what do we find x to be? 15.75, right? And so to find this, I'm just going to do 21 minus 15.75. And that's going to give me 5.25. So those are going to be my 2 answers.
savings paper for tomorrow.
Does everybody understand where these two numbers came from? If you got lost in that, that's your algebra. But do we understand where these two parts came from? All right, so yes, we're gonna hold tight on that page.